That was great. Thank you very much, Andre. I'd now like to introduce our speakers for our second presentation, Daryl Stephenson and Andrew Flanagan. We're going to be talking about ergonomics in manual materials handling, enhancing safety and efficiency.
So hi, my name is Daryl Stephenson, and I'm the ergonomist from the OHCOW clinic in Hamilton. And today I'm joined by Andrew Flanagan, who's the ergonomist at the Sarnia clinic for OHCOW. And we're going to be talking about ergonomics and manual materials handling. So today's presentation is going to cover some topics related to musculoskeletal disorders, and we'll start with an introduction to MSDs, discussing their causes and their impact. And then we're going to explore how to recognize and control for these MSD hazards in the workplace. And we'll also dive into manual material handling techniques, which can help reduce the risk. And then finally, at the end, we'll go over how to assess and manage the risk to prevent MSDs from occurring. So MSDs are painful conditions that affect muscles, tendons, and nerves, and they're typically caused by repetitive tasks or stress on the body tissues. So they can result from repetitive motions, awkward postures, sustained forces that lead to gradual wear and tear on the musculoskeletal system. So MSDs are often also called things like repetitive strain injuries, RSIs, cumulative trauma disorders, sprains and strains. And so you might hear it in multiple forms. So some of the most commonly injured areas during manual materials handling activities are going to be the lower back, which is highly vulnerable to injury, especially during heavy lifting, especially with poor posture. The vertebral disc disorders are a major concern here. Also the tendons, so the connecting tissues from the muscles to the bones, can be prone to strain and inflammation due to repetitive or sudden forceful movements. And also the wrist can be repetitively used. It can be used in so many dynamic ways with working, especially with manual materials handling. So repetitive or forceful gripping or awkward wrist positions during the lifting or pushing or pulling can lead to things like tendonitis and sprains. So we'll briefly go over some anatomy of the back. The spine is divided into four main sections. Each part of the spine plays a crucial role in supporting the body and protecting the spinal cord. So in the green down there, we see the lumbar vertebrae, which are located in the lower back and are particularly important. And these vertebrae are larger compared to the ones higher up in the spine. And this is because they are designed to bear much of the body's weight and handle stresses from lifting, bending, and the twisting motions. So as a result, they are more prone to injury when subjected to excessive loads or improper postures. Back muscles are really crucial for movement and posture. They enable the bending, the twisting, the lifting. They help stabilize the spine to prevent injury, and they help keep the vertebrae aligned. There's two main layers: the superficial layer that assists with the larger movements, and then the deep layer, which acts more to stabilize the spine and maintain posture. Okay, now we'll quickly look at the ligaments surrounding the spine, and these are going to be the tough elastic fibers that connect the bone to bone. And these fibers play a key role in stabilizing the spine. So they work by connecting and stabilizing the vertebrae in a unified structure, preventing the excessive movement that could lead to injury or misalignment. So between each vertebrae in the spine are the intervertebral discs. And often these are referred to as the spine's shock absorbers. And these discs help cushion and protect the vertebrae by absorbing the impact from the movement and pressure. However, when these large forces or awkward postures act on these discs, injuries can occur. And this can happen suddenly, or it may develop gradually over time due to repetitive stresses. And the health and integrity of these discs are really crucial for maintaining proper spinal function and preventing discomfort or long-term injury. Tendonitis occurs when the smooth gliding of a tendon is impaired, leading to inflammation. And this causes pain and irritation when using the affected muscle. And it's most commonly found in tendons that have poor blood supply as they struggle to heal after the repetitive strain. The main causes of tendonitis include things like excessive strain from heavy loads, repetition of certain movements, static or awkward postures, and these factors that place continuous stress on the tendon, not allowing it to heal properly and making it more likely to become inflamed and painful in the long run. So again, the wrist is highly flexible, can move in many different directions, allowing us to perform a wide range of tasks. And many tasks, such as lifting or using tools, can cause the wrist to flex, extend, and deviate from its neutral position. And these repetitive movements, especially under high forces and stress, without proper rest, can really increase the risk of injury, especially in these awkward positions. So one thing that can be an MSD of using the wrist over and over uh, is carpal tunnel syndrome, or CTS. And this occurs when the median nerve is compressed underneath the ligaments in the wrist. And this compression can lead to a variety of symptoms. So things like numbness, tingling, or reduced grip strength. And it's really caused by this excessive force on the wrist, the awkward postures, repetitive movements, and prolonged gripping. And vibration can be definitely a hazard when dealing with manual materials handling. And they can be categorized as either whole body vibration or segmental vibration. So whole body vibration can come from equipment like tractors and vehicles and increase the risk of vertebral disc herniation and degeneration. Segmental vibration from tools and machinery. Um, and the different frequencies that come from vibration affect different areas of the body, leading to these various MSD and nerve issues. Okay, so MSDs can develop gradually over time. So it's very crucial to be proactive in addressing the potential issues before that they escalate. It's important to take action before reaching the pain or injury stage, and indicators should trigger some action. So things like if you see people reporting pain or discomfort to a supervisor often, or taking frequent breaks to rest and recover, maybe they're shaking their hands or rubbing body parts to relieve tension, or if they're fatigued, and wearing additional products like braces to support themselves when they're doing different lifting. Maybe the wrist is hurting, so they start wearing wrist braces, or their back's hurting. We do get a lot of places, I get a lot of companies that ask me, we have a lot of back problems. Can we just wear back braces? And I say, well, really, we should be trying to design the job so that you don't have those problems and you don't have to resort to those measures, because it's an indicator that something's wrong there and that there potentially could be injuries coming. So MSDs are influenced by a variety of these risk factors, which often act in combination rather than isolation. These factors can increase the likelihood of injury or strain on the MSD system. And these risk factors don't really act alone. They often combine in the workplace to create a higher risk for MSDs. So being aware of all of these factors and trying to minimize all of them can really help reduce the injury. And when I'm going through and doing ergonomic assessments, I'm looking to see all these different factors and how I can reduce all of them. It might be obvious that a high force is the problem there, but you still want to understand that they all work in combination leading up to these MSDs. So we want to try and reduce all of them if we can. So force is a key factor in musculoskeletal disorders, and it can come in two different forms. So external forces, which are the forces applied to the body by outside objects. For example, the weight of an object being held places external force on the body. Then the internal forces, which are the forces generated by the muscles in response to the task demands. So example might be the force required by the shoulder and neck to support the arms during lifting or holding, leading to that fatigue and strain over time. So a single high load injury occurs when an extremely high force is applied to the body in a short period of time, which ends up overwhelming the body's ability to withstand the load, causing that injury. So we can see on that graph there, we have the failure tolerance, and when that load gets too high, it can overcome that, leading to injury. Repetition refers to performing the same or similar movements or tasks over a given period of time, often by the same muscle group. So when movements are repeated, the muscles under continuous strain, which requires greater recovery time to prevent the injury and fatigue. Without proper rest and recovery, this repetitive stress can lead to overuse injuries and MSDs. And the one big thing with repetition, it's about the rest time. So if you're using different muscle groups and you're doing different tasks, you are giving those muscles rest. But if you're just doing the same movements over and over, you end up using the same muscles over and over, and you end up not getting that rest time for those particular muscles. So as we perform the task repeatedly, the body faces this continuous stress, which has a significant impact on its ability to resist injury. So in this graph, we can see how the failure tolerance line there, the maximum force the body can withstand, it's going to decrease over time as these repetitive loads are applied. And each time the same muscles, tendons, or joints are subjected to strain, their ability to tolerate further stress weakens. So again, it leads us to this importance of rest. So when we apply the load to the body, it's going to cause these tiny micro tears in the tissues. And these micro tears are part of the natural process of the muscle and tendon use, but they need time to heal. So this rest is really essential for this because it allows the tissues to recover and become stronger, increasing their ability to tolerate stress in the future. So without this adequate rest, these micro tears don't fully heal and they can grow into more severe injuries. And this highlights why recovery time is just as important as the activity time to avoid these long-term damage and maintain overall muscle health. So neutral postures refer to the position that's going to minimize the stress on the body by aligning the muscles, the joints, and the bones in their most natural state. It's going to be the safest and most efficient position to work in, as it reduces the strain on the muscles, the ligaments, and tendons, and allows them to function optimally. Maintaining this neutral posture through the daily tasks helps prevent fatigue, discomfort, and MSDs. So awkward postures can significantly increase the risk of injury by forcing the body into unnatural positions. When we adopt these awkward postures, the muscles operate less efficiently. So you can see that in that wrist picture there, when the wrist is at its neutral posture, it's 100% strength. When it deviates, it can be reduced in strength down to 45% there. So this extra effort is going to lead to fatigue, more strain, and discomfort over time. So some examples of these would be bending over, twisting, overhead reaching. And these positions are going to add additional stress to the joints, tendons, making them more susceptible to injury. So here are some examples just of different awkward postures that are commonly observed in different tasks. And these, again, put more strain on the body and increase the risk of injury. And it's important to know that, you can see things here like turning your neck to the side. And if you're doing that dynamically throughout the day, as long as it's not in a repetitive fashion or holding that position for a long time, that's okay to move your body, move around, be flexible. But it's when you're working in those postures for sustained periods or when there's a lot of force while working in those postures and you're really trying to hold the awkward postures for long periods of time, it's going to add up and amplify the issues. So static postures occur when a person holds the same position for a long period of time. When this happens, the blood flow to the muscles is reduced, preventing them from getting the oxygen and nutrients that they need to function properly. And this lack of circulation can lead to early onset of fatigue and discomfort, which makes it harder to maintain that posture and perform the task effectively. So over time, static postures can really contribute to muscle strain and other MSD issues. Holding these static postures for extended periods can gradually reduce the body's failure tolerance. So the same graph here, the ability to withstand the stress and load without injury. So it's essential to change positions frequently and to take breaks and give the muscles that you're using in those positions a chance to recover to avoid the negative effects of static postures. Okay, and then there's also contact stress, which occurs when the tissues of the body become in direct contact with hard or sharp objects, resulting in increased pressure on those areas. And this direct pressure affects the underlying tendons and nerves, reducing blood flow to the affected areas over time, which can lead to discomfort, pain, and even tissue damage. And Contact stress, what it can also do is when people are working with contact stress, they often try to avoid it. So even for that computer picture there, they'll tend to shrug their arms up more to avoid that. Once that starts to be painful, they'll start to avoid it. Or maybe if they don't have those knee pads when they're moving around materials, they'll end up just bending over and working at an awkward posture for their back. So trying to eliminate this contact stress might also help eliminate things like awkward postures. So extreme temperatures can have significant impact on health of the muscles, and Andre just talked a lot about this, so I won't go into this too much, but the cold is definitely going to have an effect on the muscles and tendons, making them less flexible, increasing the risk of strains. The blood circulation to the arms and hands is going to be reduced. And then with heat, obviously, we're going to have things like dehydration, reducing the efficiency and recovery. And both these extreme cold and heat can contribute to MSDs if the precautions are not taken. Psychosocial hazards at work can significantly impact the employee well-being and contribute to MSDs as well. So some of the key hazards to look out for would be things like work demands, work organization, work values, the relationships at work, work-life balance, and the offensive behaviors that they might experience. And these factors ultimately lead to more stress for the individuals that can cause burnout and physical strain. Um, and people who are stressed, they've shown that they'll work a little more tense and their muscles will be more tense throughout the day, and their actions will be more forceful. Even when doing something like typing on a keyboard, they'll type harder keystrokes. So ultimately that leads to using more force, using their muscles more, having less rest time, and potentially leading to MSD issues. So to control for these hazards, we try to think in this using the hierarchy of controls, starting with the most effective strategies, especially for manual materials handling. We're going to try and eliminate the hazards, so remove the hazard task or process entirely if possible. If you can't remove the task, then try to replace it. So substituting the hazardous task with a safer one, such as using lighter materials, or maybe instead of carrying a load a long distance, now you can put it on a trolley and push it, or use a conveyor belt or something like that. So trying to replace that hazard. Isolate the hazard, so use barriers or automation to prevent the exposure to the hazard. Then comes things like training people on how to lift, how to do those things, rotating their jobs, rotating the tasks that they're doing, with an emphasis on thinking about which muscles groups are being used. You don't want to rotate jobs and have them just use the same muscles over and over, because you're not really getting anything out of that rotation. So when you're thinking about job rotation, you should be thinking about using different muscles, using different parts of the body in these different rotated jobs. Okay, and then the last line of defense is that personal protective equipment, the last resort, and use equipments like gloves or back supports to reduce the exposures. So can lifting technique make a difference? Yes, definitely. It can be a big part of it. If people can build these good habits, it's going to help them in the long run. It's the same idea when you're training for working out in a gym. A good trainer is going to get people in there and start off slow and light, and build that good form so that you can progress, work harder without being injured. So definitely lifting technique can make a difference. So we'll go over some of that now. So lifting and carrying items can pose a risk to your back's health, but using safe lifting principles can help you protect your back and keep you comfortable. So we use this BACK acronym, so principles of lifting, so trying to keep the back straight, avoid twisting, keep the items close to your body, and keep the motion smooth. So when the back is straight, the discs in your spine can handle larger loads without the risk of injury, compared to that bent picture. And you can see with those two pictures there. So to maintain a neutral spine position, always bend at the knees and hips, not just the waist. And this can ensure better alignment and reduce strain on the back. Maintaining a neutral spine helps to align the torso and preserves the spine's natural curves. And this is going to help keep the torso moving smoothly and reduces the stress on the muscles and the discs. ultimately preventing strain and injury. So avoiding twisting is going to be a big one. Twisting while lifting puts a lot more strain on the spine as the discs are weaker in this position. To avoid this injury, always try to pivot your feet and move without twisting your torso while moving objects. And this ensures the body's mechanics and reduces the risk of strain. And I see this one quite often when I've been to different places for ergonomic assessments. I see a lot of people just twisting the whole time and really working on, okay, pivot, move your whole body, almost like you're a robot twisting your whole body and you can't twist. Try to figure it out that you can do it efficiently without just twisting, because that twisting is going to put a lot more strain on your spine. When lifting, your back joints act as a fulcrum, and your muscles really counterbalance the weight of the object. So the further the object is going to be away from your body, the more stress that it's going to be placed on your back. So to reduce this stress, try to keep the object as close to your body as possible. Also trying to raise the center of gravity of the object. So getting the object higher before you have to lift it up is going to reduce the force required to lift. So we can see here with these ideal places to lift on the picture to the right, the green zone, trying to lift from that area, trying to avoid the highs and the lows and far away. So to protect your back, always keep moving smooth while lifting. Avoid sudden, forceful movements, as they're going to increase the strain on the discs. And similarly, try not to release the force abruptly, as it can cause injury. So right when you get to your destination, don't just try to drop it or release it. And especially when you're lifting with a partner, you're going to want clear communication to make sure that all the force doesn't land on one person at once, and make it smooth and coordinated. So lifting is going to be affected by, obviously the object weight. If things are too heavy, object size, the symmetry, the vertical and horizontal location, and the grip. And I saw a comment that just popped up. Yes, if something's definitely too heavy, don't lift it and test it. Go and see, and if it's, you don't want to put yourself in any position where you could be injured, and that job should be changed. Heavier weights are going to increase the difficulty of lifting and increase the likelihood of using poor technique and the risk of injury. So try to use lifting aids where possible, or get help from a partner, test the weight, and always use proper lifting technique. But if it is too heavy, don't lift it. The vertical distance, and like we've seen in that other picture with the red and the yellow and the green, affects the difficulty of the tasks, so increases reaching and heightens the risk of injury, really decreasing safety. So try to keep those heavier objects lower, around that knuckle to chest height, and try to minimize that vertical travel distance as much as possible. And really just try to avoid overhead work when possible. Similar to keeping it close to the body, just increasing the horizontal distance from your torso is going to increase the effort and the force required. The dimensions of the object can also affect the lifting. So larger objects increase the difficulty. They decrease the grip and the control. So to reduce the strain, always aim to decrease that horizontal distance as well. Unbalanced lifting can also lead to awkward postures like twisting or leaning, which can create unbalanced force production. This is going to increase the stress on the muscles and the discs, and potentially raise the probability of injury. So try to avoid just single-handed carry with very heavy loads for long times. Try to balance the loads out where you can. Use lifting aids again when possible, and get help from a partner if you need it. Your grip is definitely one thing to think about. Can have a large impact on the forces required. Poor grip or poor coupling increases the risk of injury by reducing the control and increasing the strain on the hands and the wrist. So avoiding things like slippery objects or using pinch grips or awkward grips, awkward shaped objects, or understanding the differences with different gloves. and making sure that you have good gloves that fit you. If you're wearing gloves that are too small, you're going to be squeezing a lot harder just to do the same tasks. Or if your gloves are too big, it could be awkward and loose and slippery. So making sure that you have fitted gloves, that they're the proper gloves for the proper task that you're doing, right? Really, really thick gloves can add to the grip strength that you have to use for certain objects. So making sure that you have the proper gloves for the proper tasks that you're doing. Okay, so there are different products out there too. So to minimize, aim for a firm, secure grip that's comfortable. There's tools out there that can add to your grip for different objects. So it can be useful to look around for these. There's all different types out there. So depending on what task you're doing, there might be something out there that's designed to make your grip a little bit better. Okay, and just quickly for vibration, controlling for vibration, just in general, report any poorly maintained equipment to your supervisor, ensure good suspension systems and correct tire pressure. If your seat has hydraulic dampers or shock absorbers, make sure to adjust and fit it for your weight and your height. Slow down when driving over potholes or rough terrain, and take the breaks that you need. Get out of the vehicle every hour or so to stand, stretch, give your body a break from that vibration. So in some situations, the standard lifting technique may not be feasible due to the object or the task that you're doing. And in these cases, an alternative lifting technique can be used to reduce strain and prevent injury. In the next 3 slides, we have 3 videos demonstrating some different lifting techniques for the various scenarios. And it's actually Andre from the presenter from the previous heat stress, who's in these videos doing these.
Use the partial squat lift for small light objects with handles close to knee height. Stand with the object close to your side. Place your feet shoulder width apart. Keep your back straight. Push your buttocks out and slowly lower yourself down to reach the object's handles. Prepare for the lift. Grasp the object and look forward. Lift upwards following your head and shoulders. Lift by extending your legs with your back straight, your buttocks out, and breathe out as you lift. Use the partial squat lift for This lift is used for bulky or awkward items at floor level. Put one foot next to the object. Keep your back straight. Push your buttocks out and slowly lower yourself down onto one knee. For support as you lower yourself down, put one hand on a stool or on your thigh for support. Position the object close to the knee on the ground. Grasp the object firmly with both hands. Slide the object from the knee on the ground to mid-thigh. Keep your head forward, your back straight, and your buttocks out, and lift the object onto the opposite thigh. Put both of your forearms under the object, with your palms facing upwards, and hug the object to your stomach and chest. Prepare for the lift looking forward. Lift upwards following your head and shoulders. Hold the load close to your body. Lift by extending your legs with your back straight, your buttocks out, and breathe out as you lift.
So that one's a good example of trying to raise the center of gravity of the object. He's getting it a little bit higher up onto his leg there before actually doing the squat movement up. So that's, again, trying to raise the center of gravity there.
This lift is appropriate for light objects that can be lifted with one hand. Place hand near the edge of a fixed surface if possible to support your upper body during the lift. Keep your back straight and raise one leg as you lean down to pick up the object. The weight of your leg will counterbalance the weight of your upper body. Grasp the object firmly. Prepare for the lift. Look forward. Keep your leg raised as you start the lift. To lift, keep your back straight and breathe out. This lift.
Okay, so now Andrew is going to take over.
All right, thanks, Daryl. I'll just try and share my screen here. So if you just let me know if you're able to see it.
Yep.
Yeah, okay, great. All right, so I'll just jump right in where Daryl left off here. So when carrying loads to protect your back, you want to move at your feet and avoid twisting. Keep the load close to your body and maintain a neutral posture. If the load is too heavy, use a wheelbarrow or a cart to minimize the risk. Looking at pushing and pulling tasks, when using a device such as a cart or a dolly to move a load, we should consider human factors like height, strength, and age, along with task demands such as distance, force, duration. Equipment design matters too, so things like handle height, handle design, wheel type, and stability all affect performance. And lastly, we want to check the floor conditions to be aware of anything that may increase force requirements like matting or soft surfaces. In order to reduce strain and minimize the distance that you push or pull, we can relocate and reorganize materials and make sure our layout is efficient. Also, we should always avoid pushing carts through crowded areas by having a route plan prior to starting the push to prevent accidents. Whenever possible, we want to eliminate pushing and pulling by using tools like conveyors, powered trucks, lift tables, or slides to move loads more safely and efficiently. In order to reduce force when pushing or pulling, we should improve our grip and reduce the load size. So this may mean taking multiple trips if needed. We should always use dollies with low centers of gravity, excuse me, and a wide wheelbase to improve stability and control. It's important to ensure that preventative maintenance is completed on these carts for smoother movement. Finally, we always want to make sure that our floors are in good condition, eliminating and maintaining cracks and bumps, and ensuring that we have proper footwear with good grip and traction. In order to optimize pushing and pulling tasks, we should eliminate one-handed movements where possible. Always use both hands for better control and stability. Excuse me, sorry. Providing adjustable handle heights can help accommodate employees of different heights, and having vertical handles helps to maintain more neutral wrist posture when pushing or pulling. We should always try to use ramps with a slope of less than 10% to make pushing easier and safer. Additionally, we should keep the load within our more powerful range, so between our mid-thighs and our shoulders, to minimize the risk of injury. When moving objects, we should try to push instead of pull for better efficiency and safety. Pushing helps better utilize your body weight, giving you more control and power over the movement. With pushing, you can see the travel path ahead, and this reduces the risk of coming into contact with obstacles or misdirection. Pushing allows you to use both hands as opposed to just one, and it offers better stability and control. And finally, pushing keeps your spine aligned, preventing twisting and reducing strain on your back. When performing a push task, we want to keep our hands below our shoulders, closer to waist level, without bending at the back, so we want to maintain that neutral posture. And this allows the push force to be directed through the lower back and allows for use of stronger leg muscles. Similarly, when we're performing a pull task, so in this picture, this person's about to open a door, we want to keep our hands between shoulder and waist height to allow the force to come from our leg muscles in a neutral back posture. As you can see in the photo, the worker in the photo on the right, the worker is likely going to have to utilize the muscles of their back, upper back and shoulder, and it's probably going to result in some twisting motion to apply the force. Whereas in the picture on the left, the force can travel right through the lower back and avoid the twisting motion. Okay, getting into hazard identification and risk assessment. There's some research out of Belgium that discusses the various levels of hazard identification using the acronym SOBANE. So in this, 60% of workplace hazards are identified at the screening level. Workers identify hazards based on their first-hand experience by utilizing things like body mapping, surveys, or OHCOW apps such as Painpoint or Hazard Assess. At the next level, we see 25% of hazards identified, And this type of investigation can be done by joint health and safety committees, includes tools such as checklists or the OHCOW app Job Assess. At the analysis stage, we see 12% of hazards identified. And this is a detailed, more quantitative evaluation that's often conducted by health and safety professionals using tools such as RULA, REBA, Liberty Mutual tables, and many more. Finally, we look at the expertise level. So at this level, external experts are brought in to address complex issues beyond the organization's internal capacity. And this could be using tools such as human modeling software or conducting studies to quantify and solve a problem. So we're going to go through the bullet points on the right of this slide in greater detail on the coming slides here. So working our way through hazard identification and risk assessment lists, we'll begin with body mapping. Body mapping can help to identify common health and safety issues and workplace risks. It helps recognize problems and the need for further investigation and helps communicate these findings to stakeholders. Body mapping is a simple visual tool whereby a worker marks their places of discomfort on an image such as the one that you can see on this slide. So if they're experiencing shoulder discomfort, they would mark an X on the shoulder to indicate that they're experiencing discomfort there. Some of the benefits of body mapping are that they encourage discussion, so workers can easily report symptoms and share experiences, discussing what they feel may be contributing to their discomfort. It's simple and they're visual, they're easy to use, and they're widely understood. So even people who have language or literacy challenges, language barriers, not affected in body mapping. If completed on many workers, body mapping can identify trends and can reveal common health and safety issues in specific jobs, areas, or workplaces. Moving on to surveys. Surveys can be an effective way to identify workplace hazards by gathering feedback directly from workers. They can identify hidden risks and capture hazards that might otherwise go unnoticed. Surveys can be anonymous, which can encourage participation and provide valuable insights. Surveys are simple, flexible, and can be customized for specific tasks or concerns. And they can also help prioritize safety improvements based on real data. When developing surveys, it's important to take the bullet points on the slide into consideration, just to ensure maximum effectiveness of the survey. Looking at checklists, checklists provide a structured way to identify hazards. Talking to workers gets firsthand insights. Observing work helps to see how tasks are performed in real time. Findings from checklists can be documented by taking notes, drawing diagrams, and capturing photos. And finally, checklists can help prioritize action by using findings by deciding where to place focus. Some of the strengths of checklists are that they're simple to use and easy to administer, making them an effective hazard identification tool. They serve as a reminder to observers, ensuring that critical factors are not overlooked. Checklists can help define relationships between various factors, and they're particularly useful for breaking down operational procedures. The method provides reliable results with high consistency among different observers, evaluating the same activities, which can reinforce the validity. Checklists also have limitations, as they offer little insight into specific problems and only highlight risk factors without promoting deeper conceptual thinking. So the yes-no format can make it difficult to argue for change due to the lack of detailed information. Checklists provide no assistance in generating new ideas, and ultimately they represent only the first step in the hazard identification process. This is just an example of a checklist that can be used to identify MSD hazards. So it lists various hazards and allows the user to check off if they have been exposed to that hazard. So checklists are strong, simple ways to identify when a hazard exists if it's included on the list, but they lack where there's missing information. So therefore, it's important to work with stakeholders and ensure that checklists are properly developed to be all-encompassing. Moving into some of the apps that can be used, the OHCOW app Painpoint provides a basic ergonomic assessment displaying results on a body map. It offers recommendations to address work-related musculoskeletal disorder hazards and allows users to share their results summary. The app also stores a history of results for tracking progress and allowing follow-ups. So this app is available to be downloaded in the App Store on your smartphone. It can be found on our OHCOW website. Hazardous is another OHCOW app that was developed by OHCOW in conjunction with Canadian Centre for Occupational Health and Safety, or CCOHS. The app allows you to take action to reduce or eliminate health and safety risks in your workplace by guiding you through 12 distinct health and safety topics that prompt you to describe the hazard, identify its source or cause, and to provide ideas on how to fix it. It also allows you to take pictures and mark them up with circles and arrows if needed, and then from there you can create a PDF report that can be emailed to applicable health and safety contacts for follow-up. Prevention resource links are also included in the app so that you can learn more about various hazards and the associated risks, along with ideas on what changes can be made to improve workplace conditions. Taking a quick look at RULA here. So it was developed by McAdamy and Corlett, and it provides an easily calculated rating of musculoskeletal load in tasks where people have a risk of neck and upper limb loading. The tool provides a single score. It's a snapshot of the task, which is a rating of the posture, force, and movement required. So this tool depends on accurate interpretation of postures to produce accurate scores. Limitations of this tool are that RULA only acts as a snapshot to provide insight. So it's only based on posture, single posture. It does not consider duration, recovery time, hand-arm vibration, and it is unilateral. There's also REBA, which was also created by McAdamy and Hignett. And REBA was completed similarly to RULA, but it aims to capture the entire body posture. Similarly, REBA provides a single score as a snapshot of the task, which is a rating of the posture, force, and movement required. REBA was designed to be sensitive to the type of unpredictable working postures found in healthcare and other service industries. Moving into the Liberty Mutual tables, data is entered into a calculator, as I'll demonstrate in the couple coming slides here, in a couple slides. Excuse me. And the metric that's derived from the calculator is the population percentile. So this is the percent of the population that can be expected to do a specific task and quoting without straining themselves or without becoming unusually tired, weakened, overheated, or out of breath. The score can be calculated for lifting, lowering, pushing, pulling, or carrying tasks. And the Liberty Mutual manual material handling calculator tool is available to everyone at the link at the bottom of this slide here on the Liberty Mutual website. So with the Liberty Mutual manual material handling calculator, musculoskeletal pain or injuries do not only occur because of the severity of the task parameters. So based on this, they should not be evaluated based solely on population percentages. Other important considerations are if a job is causing injuries, it should probably be redesigned. Frequent bending, twisting, and reaching, regardless of weight, is not recommended. The tool does not evaluate one-handed tasks. Overall, the tool should be used for designing tasks so that as many workers as possible, speaking as percentage of population, can perform the task without risk of injury. So I apologize for the size of the image here, but if you can see the titles and then the units that have been entered. Just as an example, the categories of information that we need are task type, system of units, hand coupling, frequency of lifts, so lifts per minute, object weight, start hand height and end hand height, start hand distance and end hand distance. Once we have all of these things entered, we select calculate at the bottom there, and in the box to the right, you'll see the population percentage capable of performing that task. So in this case, we have 5 lifts per minute with a weight of 30 pounds. So it's, a lift. Almost every 12 seconds you're doing a lift. And it's quite heavy, 30 pounds. So based on this, less than, we can see in the box on the right, less than 1% of the female population is capable of performing this task. So in this case, it would not be considered a safe task, and we would want to redesign this to make it so that a larger portion of the population was capable of completing. Generally speaking, that's 75% of the female population. OHCOW also has Job Assess app that can be found on our website at the link here, and this can be used to accurately and efficiently perform a job demands analysis. It could also be used to just look at a specific task if you wanted to. So a My OHCOW account must first be created so that reports can be saved, so you can access later to view the information or update the reports as your jobs change. Getting into Job Assess, the app allows users to select the unit of measurement as well as what they want to capture in the assessment. So like I said, if you only wanted to capture the psychosocial factors, or if you wanted to just look at the physical demands, you could just select those boxes, and then that would be what was presented to you within the app moving forward. There's 9 different sections if you're completing an assessment for all areas. Otherwise, only those selected will show up. So you can navigate between sections by selecting the icons. And as I mentioned before, your work is saved within your My OHCOW account, so it can be accessed at a later date. As you work through Job Assess, there's options to select red flags associated with each area of concern. So if you're completing something and you identify it to be a high-risk activity, or if a worker says to you, this is really challenging for me, and that could be a way that you may identify that it should be flagged. And all of these flags and notes will be captured in the final report to help you go back and read the summary. Sections related to physical tasks include a Borg scale to capture rating of perceived exertion to allow for some qualitative input. So as you're evaluating or completing this analysis and you're working with a worker who may be completing the job, you can ask them, what is your rating of perceived exertion when completing this task? And that can give some insight into the difficulty of the task and how the workers are feeling about it. Reports are generated that show results that can be saved and exported as a PDF. And these can also be exported as a CSV or Excel file, where the data can then be further sorted to identify high-risk categories. Or if you wanted to compare results between jobs or departments, you'd be able to do that there. Having a saved bank of JDAs would allow the user to make to make small changes. So as I mentioned, they are saved in your My OHCOW account. And you can go back and make small changes to the job without having to go in and recreate an entire report. And the picture on the right here, these are just, they're not real assessments, they're just examples of how your page would look when you're logged in. Okay, and that wraps up assessment tools. So in summary today, we went through an intro to MSDs commonly associated with manual material handling. We discussed how to identify MSD hazards commonly associated with manual material handling. We discussed common MMH tasks, and we introduced methods for assessing risk associated with these tasks. And I know this was a lot of information between what Daryl and I just presented. So yeah, please know that this presentation will be available on OHCOW's YouTube channel. And I think it's also available as a PDF of the slides. Please also keep in mind that OHCOW ergonomists are available to work with your Joint Health and Safety Committee in Ontario to identify risks and help you develop solutions to control some of these risks. So with that, if there's any questions, Daryl and I are happy to take questions.
Okay, thank you, Andrew. Just a reminder, if people could please take a few minutes to complete the post-survey questions that are popping up in the bottom right of the screen. And with that, I'll turn over to Dwayne to answer or ask any questions of our speakers.
Thanks, Trevor. Thank you, Andrew and Daryl. That was a very good presentation. There are many questions that were posted in the chat, but a good majority of them were answered throughout the presentation by Andrew and Daryl. So we're only going to hit on a couple of quick ones here. Can you guys define the word repetition or repetitive in terms of how you used it in the presentation? Daryl is muted. Oh, go ahead, Andrew.
Yeah, I can answer that. So repetition, I think a lot of times we think about it as, when people think of repetition, they think of repeated movements, something like work on an assembly line, where you're doing the same thing over, numerous times a minute or days or hours. And that certainly could be considered a repetitive task. But I think a better way to think about repetition is repeated stress on a body segment without adequate time for recovery. So, you may be rotating between tasks and you may be moving something totally different, but if you're using your arms and picking it up and carrying it around, and you're using those body segments and muscles, tissues for extended periods of time, it should still be considered a repetitive task. I don't know if Daryl has anything to add to that.
Yeah, that's basically what I would have said. It's a lot of times I have read examples and definitions that are based more on the movements being repetitive. If you're doing it more than half the time on your, within an hour, if you're doing it more than 30 minutes. But really, we should be thinking about, how much you're using it and if you're getting rest, because you could be doing different movements. You could be holding static postures that are all going to add up to needing more rest time. And are you using that muscle repetitively and enough that you're not getting the proper rest and you're getting symptoms later down the road?
Great answers, guys. Thank you. One more quick one so that we can keep in mind time here. Like I said, most of the questions were answered throughout the presentation. Do you guys have any tips for manual lifting of patients and stretchers, or patients in stretchers, I guess?
I do have, it is quite a bit of a big topic. Definitely understanding how dangerous it can be to lift anyone. There's recommendations that you need, more than 2 people for anyone that doesn't have full control of their body that's over 35 pounds is kind of the recommendation. So definitely using lifts and aids wherever possible. But I do have some presentations on that. If whoever wants to email me, I'll email them my presentation on that topic, which is shows a lot of different examples that you can use.
I'd like to thank everyone for attending today. Again, have a happy Valentine's Day, and hopefully we'll get to see you all again next week.